Okay, this story is referring to type inference in arrays and tuples. So first of all, we got here, I'm talking about arrays, okay. I'm making an array here of car makers, and I'm just setting it as not defining any values in it, just declaring it, not initializing it. Then after that, I initialize it with some Ford, Toyota, Chevy. And as you can tell, type inference is not occurring. It's just using an any because it doesn't know what types they are when I declared it. So when I come down here and I look at the cars, if I go and grab the first element off the car makers, it still doesn't know what it is, and type inference isn't going to help us at all. And it's still going to give this an any. And if I look at, if I pop it off, the last element in the array, my cars is still going to be an any. So, you know, type inference is just not present here. Even though I'm basically wanting this to be a string, everything in this array I want to be strings. If I put a number in there, there's no error, there's no problem. So that's also an issue. And if I put a string in there, which I do want, also there's no error, so it shows no difference. If I try to map out the values from the car makers, I can't see what type this specific element is. It's also an any. And if I come down here into the car and I look and I see what is the intelligence on it, yes, I do have two uppercase intelligence, but it's not narrowed down to everything, only the things that are in a string. You know, it's got everything in there. So for all the different types, because it's an any. So if instead of doing that, we use the standard type inference, what I've been doing in the last story, which is not only declaring it, but initializing it all in the same line here. Then we, instead of having any, we got a string. We know it's an array of strings. Great. And then when we come down here, we get the additional assistance. It's basically a second-hand assistance to do things like pulling off the first element. The first element we know is a string, so type inference is going to work here and say, no, that's a string. Great. When we pop off the element off the last array, that's a string. So this is going to know this is a string as well. So this is defined as a string. So it's kind of second-hand type inference. We try to stick a number on it, no good. You know, that's got to be a string. It already knows that. String right here. And if we try to put a Honda on there, it's a string. That's good, no errors. We try to map out the elements in there. We have here that's the string of elements. String, I didn't type that in. That's in my IDE. It's coming out already. It knows that the element in there is a string. And we come down here to the intelligence on it. We can see it's limited to only string property or string methods I can call on here. And there you go, right here. Easy to work with. Okay. Talking about flexible types, where you have more than one type in an array. If I do the same thing, I just initialize it, or just declare it without initializing it. I come down here and try to, let's say that I want it to have just what I put here, string. It's a flexible type array, and I want it to be both a date class, capable of taking in a date class, or just typing in the date as a string. Okay, so I add them both in here. That's good. It's exactly what I want this array to be able to take. But I don't want it to be able to take numbers, but hey, you know, it's going to take a number too because it's of an any type. Because I'm not initializing it when I declare it. So instead, I come over to here and do the standard. No, not the standard. This time I'm going to explicitly type it here with the date or string. So we got flexible multiple types in a string or in an array. I come over here, I can add the string, I can add the date, and I can't add the number. That's exactly what we want to happen because we can see what's in here. It's a string or a date. Great news, but instead of explicitly defining it, we can again let type inference handle flexible types as well, as long as we are initializing when we declare them. So we tell what the values are, we tell a couple values in here. It knows already, okay, this is a string or a date, and we get the same thing down here. These worked, and the number type did not work. All right, now let's talk about tuples. Tuples basically are very similar to defining an object where you have properties and values in the object. So here I got a drink object, and I say a drink. The drink can be the color drink, brown, carbonated or not. Say it is carbonated, true. And how much sugar is in it? 40 grams, for example, whatever, it's 40. Okay, if I come down here and try to put, instead of doing it with an object, I can do it with what's called a tuple. So I can define an array and just say each element in the array is one of the properties. So we got brown, true, and 40. For brown is color, true is carbonated, and 40 is sugar content. Okay. Well, if we were to assume that type inference would figure out, hey, this should type this correctly with a tuple, I can hover over this and we can see that we got the types in there correctly by type inference: string, Boolean, and number. But unfortunately, they're not in the right order. It's string, number, and Boolean. So basically, you can't know exactly if you're typing if you're giving in the right type in the right order, because it's got to be ordered correctly. So the better option is, instead of, unfortunately, can't use type inference in tuples. So we should specifically say explicitly, this is a string, Boolean, number with Typescript. And here we see string, Boolean, number in the correct order as it is up there. This is a string, this is a Boolean, this is a number, and everything's happy. But what we can also do, instead of it doing that way, is we can come down here and we can define a type class or a type and say that's string, Boolean, number, and define that as the type of my object. And then we look at the object here and it's of type drink, but if I click on the drink, we can see that is a string, Boolean, number. So that's turning out well, and we can assign the values to it right there as well. So tuples can, it's kind of tricky. You shouldn't really use type inference with tuples. You should be typing it specifically. That being said, tuples aren't used very often. They are used with comma separated string values files often, but a lot of times in code, you're not going to use tuples because they work fine. The problem is programmers don't understand them, because programmers, when they see brown, true, 40, they don't know what does brown mean, what does true mean. In the code, it's always nice. It's almost always what you want to have is to have the properties with the values together, so you know what these things are when you're programming them. So that's the end of this story. Thanks for watching.